So, GraphQL. We've had a couple of great talks about stuff which I personally am either very interested in, like GraphQL, or absolutely hopeless at, like building forms on the client side. And this is a little chat about what we do at Musical.ly in the GraphQL kind of space. Turn it on, helps. So I'm John Maxwell, I'm the CTO. You can tell by my extreme technology skills. You can find me on most of the internet at JGW Maxwell. I've been at Musical.ly now for 6 years. Of the 11 and a half we've been claiming we're a startup in London. At some point, apparently, we have to stop saying that, but I'm under absolutely no rush to do so. In terms of who we are, if you haven't heard of us, we're a global e-commerce platform serving the music industry specifically. We've got a number of bespoke solutions, some of which are quite interesting, some of which are absolute maintenance nightmares. But the key thing that we do is we are essentially building marketplaces for bands. So if you think Amazon, but swap a band name in instead of Amazon, that's kind of what we offer. And there's a really good reason for that, which is that in our sector, almost the entirety of the marketing reach of the influence comes from the band themselves. But at the moment, they're totally bypassed in terms of everything that they do in favor of record labels, in favor of the concert promoters. And in 2018, people are realizing that without the band's marketing reach, they can't do anything. So you're getting Ticketmaster trying to press gang bands into tweeting the shows that has actually no benefit for the band whatsoever. So essentially our proposition is that we just unite all of those flows together through the band's own store and allow the rights holders, wherever they are around the world, to get paid correctly and to get the fans served the right products for the part of the world that they're in. We operate in a hype industry, as I don't know if anyone else does. We have some interesting traffic characteristics. And this talk essentially is the story of how we've tried to leverage GraphQL to solve some of our internal problems and also some of our scalability issues. It hasn't all been plain sailing. I am happy to admit that. But hopefully there'll be a couple of lessons which you can take away from this today. We work with, again, little people. We work with some big bands. And what happens with the biggest names is that they have very, very specific challenges. We'll come to those in a second. Our story of GraphQL starts, that's going to be hard to read, in September 2015, when I pushed the initial commit to one of our 5 main projects. We have 5 different graphs servicing different things from admin interfaces all the way through to our actual main production customer-facing stack. Shortly thereafter, I pushed another commit. If you know me, this will be no surprise. The only surprise will be that there wasn't a series of expletives after it in a third commit message, as I tried to pretend that I know what I'm doing. These days, we have maybe got a bit of a better grip. We currently average about 200 requests a second through our primary graph. However, that has a slightly funny kind of profile. Because we love graphs, GraphQL, little joke there. Oh, lovely. This is roughly what traffic looks like for a single one of our clients. I mean, this isn't anyone in particular, but this is the kind of traffic flow that we deal with. So it goes from essentially totally idle to not very idle, and then back down again very, very quickly. We work with in the region of 50 to 60,000 different acts. And as you can guess, that becomes quite interesting in terms of the challenges that we deal with in managing this kind of behavior across so many different people. All you need is 5 or 6 of the biggest clients to independently decide that Friday looks great, and then suddenly you've got a nightmare situation on your hands. It's also interesting that we, and we'll talk about this a little bit in a second, have quite a microservice-based architecture, and each request is likely to pass through GraphQL on a number of times, at least once on the server side, and then on the client side, anywhere up to 5 times, depending on what page is being rendered. We'll talk about some of the decisions why we ended up with that point. This means that our traffic profile has roughly a 10,000 factor or range of fluctuation between, like right now, and what might be happening at 9 o'clock tomorrow morning. And I have absolutely no idea what will happen in that period of time. We'll talk about how we fix that as well. One of the things that we've worked out quite quickly is that GraphQL is not exactly a transit efficient way of doing business. A lot of data tends to flow around the world, and in our case, it tends to be quite chunky. Our smallest responses are at least 15 kilobytes. Our largest responses are significantly larger than 128, but depending on what is being rendered, we have to provide a superset of all the data that might be required. People are free to build their sites however they wish, and we essentially have to guesstimate what data could be on the page. There are two avenues about why that's done or why that's necessary. We'll talk about those a little bit later on. But there are interesting challenges in just pushing that much data down a wire for a single request. Obviously, it's e-commerce, so latency is a huge issue as well. We set an internal target of shutting down the television in 50 milliseconds. So what that kind of means is that during an average kind of peak period, then we're dealing with about 10 gigabits of actual GraphQL traffic through our internal interfaces. That's an awful lot of curly braces. It's an awful lot of at directives. And also, some of it, we'll talk about in a bit, is probably unnecessary. So how did we end up where we are? And this is maybe some of the interesting stuff. I said we've been here for 11 and a bit years. We've been through 5 major generations of our e-commerce stack in that period of time. Fortunately, I haven't been involved in all of them. Otherwise, the beard would be grayer. But we started out as a .NET shop, and that was great. We didn't really do distributed at that period of time, so that meant that whenever that server got a bit busy, we put up a great big come back soon kind of page and asked people to just reconsider how urgently they wanted those tickets. From there, we heard about something called WordPress, which I'm sure some of you have heard of as well. It's great. I won't have anyone knock it. But it is an expedient way of building applications, and we might just talk a bit about why that is maybe relevant again in 2018 shortly. We moved from there into being a pure PHP stack, which we pushed and pushed and pushed until we detonated. Several times. We actually took Heroku offline in Europe twice. If you were involved in that, I apologize entirely. It turns out that they do have the 100 limit on the slider for a really good reason. And if you ask them to lift it, then bad things happen. Where we went after that essentially is to GraphQL. So we've done kind of one major rebuild, which is to drag everything into GraphQL. That happened 3 years ago. And then 2 years ago, we realized that we made some terrible decisions and started again slightly in how we envisaged that. I said before, people can kind of theme their sites and their stores and work out how they want to do that themselves. So we thought to begin with, well, React is the hotness, so everything must be React. So we built a rendering framework. In React, we used GraphQL to power it, and that worked absolutely fine until we tried to load it on a mobile phone. This is what happens when you don't have front-end specialists. No one tells you that, like, check Android as well as iOS. So we rethought at that point in time, and we retreated slightly. So we kept the GraphQL part of it, but then we used server-side rendering with Liquid in Ruby. We do have quite a large Ruby presence on the back end. And then we built a React framework, which essentially is like a micro framework. So a pile of tiny little widgets in React that correspond to a shopping cart icon or an add to cart button or a download my calendar link. And then they all communicate over Redux, which is still the live stack right now. If you go to Iron Maiden's store, that's exactly what you're looking at. As part of that, we also thought, well, why would we want one giant PHP application when we can write 19 giant JavaScript applications instead? Honestly, it doesn't actually matter how micro your services start. They never end up there. And I think all that really microservices is a way of increasing the number of lines of code that can be deployed without anyone noticing. Ultimately, though, at the start, at the center of this kind of network of like responsibility circles, so kind of like events are managed by one thing, products are managed by another. We've got a tier of 3 different GraphQL services, one of which is the public one. We've got an administrative one that enables us to do our jobs, and then there's like a private one that deals with like offline warehouse integrations and stuff like that. That has been actually a joy. And whilst I am skeptical about some parts of it and will always remain skeptical, we have a weekly meetup called the Refactor Tractor for a reason. And even though I'd love to change a lot about it, the GraphQL stuff has been a rock in that period of time. And I think it's been a rock for some reasons we'll talk about shortly. This is the talk where I say we'll talk about it soon. So at the end, there's going to be like one slide with 1 million points on. You can read it in 3 seconds and then go home. We've also kind of then developed a lot as engineers over that period of time. And I think the moment you start doing functional programming is the moment you start really thinking about what you're writing a bit more. We've moved to TypeScript wholeheartedly. We've also embraced a more functional way of doing that as well. There's a cool set of projects, PGTS, which is ours, which is a database library. Didn't mean to plug that first, but anyway. There's IOTS and also FPTS, which are kind of functional and runtime typing libraries from a guy called Gcanty on GitHub. They're awesome. I would check those out. And we really went deep with the typing of things. So we found a project called GraphQL Strong, which enables us to not write GraphQL at all in the Apollo kind of way of doing it, but just everything is TypeScript, like all the way through. Your resolvers are TypeScript, your context is TypeScript, the args that come in are TypeScript. And that has been really good. It's enabled us to have a much better foundation of where we reason about projects. But we're also one of 5 maintainers of that project, and the other 4 haven't committed in 2 years, including us. So, like, there are some interesting challenges ahead on that front, and I think that's one of the interesting and one of the difficult things for us as a community, as a JS community at the moment, is the fragmentation of all of the things is accelerating. And I really enjoyed your talk about form libraries. We've written 3, we don't use any of them. Yours, though, is the first time that I actually believe there is a good reason to write one, which was the meh. All of ours were written because we thought we could do better, which has been proven to us that we can't. And I think that's kind of like one of our kind of takeaway points about where we're going to try and go from here, is to say, actually, when we look at it deep down, what are we trying to achieve by doing this stuff? And okay, we can lock in the behavior of where we are this week, and we can reason about everything that we're doing right now. But what does that mean for a year's time? What does it mean for the next time there's a major breaking change in GraphQL for a security reason and stuff? And there's definitely risk factors there, which we haven't managed to explore fully ourselves. So this is kind of the story about where we went. We had our young love phase, which is a lot of the reasons we kind of touched on there, which is that everything is wonderful when you pick up GraphQL the first time. Like, absolutely brilliant. You know, it's like pigeons in the Eiffel Tower. It's finally being able to just sit down as a team and say, you know what, actually everyone understands what's going on. Well, that's hard to read. Everyone understands what's going on. There's a common language. There's a common way to reason about applications that you're building, because a lot of the plumbing's been taken away from you. There's not very much that you can disagree on, because the spec is so comprehensive in its nature compared to arguing about, is this actually okay to have another REST action here, or should we nest this under that controller? And like, what happens if you publish a product? Are you creating a publishing there, or are you amending the state? And all of these conversations just disappear. From there, we decided, well, okay, we've now got a really good common parlance. We can use this to communicate effectively as a team. So we can use it for everything. Rapid growth ensued. And that led to us really buying into it. We had scalars for absolutely everything. So a scalar is a GraphQL term, if you're not familiar with it, for wrapping a specific type of value in a predictable way, such that you can pass it over the wire and be able to interact with it in the way you expect at the other side, and it offers you validation and kind of runtime things like that as well. They're really good. I mean, I think at one point we actually had a coffee pot fill level scalar, which is the first hint, the first part of a realization that Houston, we might have a problem here. It turns out that GraphQL actually has an upper limit in terms of what you can do with it, which is partly why we've ended up with multiple graphs. But there's a scale factor where you can't push it beyond. And it's not at 50 resolvers, it's not at 50 types. But by the time you get to 1,000 of them, then you really start to have issues, literally just booting JavaScript, if nothing else. But all of the things that made it really good, like we've got a single platform that everything can interact with, we've got a single language, actually becomes a really big hindrance because there's no way of stepping back and asking yourself, actually, what are we doing at the moment? What happens when you realize that you can also do bad GraphQL? So for us, the moment that we were doing bad GraphQL was when we realized that our small queries were really good. Like you ask for a little bit of data and it gives you back a little bit of data and everything works really, really well. But I said earlier on that we were kind of passing a couple of 100 kilobytes of data across the wire on a single request, and we were wondering why it was quite hard to actually push things and to scale things and to go forwards. Once you've started modeling bigger and bigger parts of your ecosystem and you start saying, okay, you know what, I'm going to build this page and I'm going to query for all the data on the page at once in the way that, say, Relay wants you to. Like, if you're talking about a product catalog with endless variants and stock levels and prices and availability restrictions, and because product want to have some really nice features on there, like, okay, we'll show this icon if this is the case, and it wouldn't be that hard to add this in, then you can easily end up in a situation where actually the scale of it is huge. And I think anyone doing GraphQL should ask themselves, how can we keep it as small as possible? Like, it's okay to make multiple trips to the server in a world where HTTP 2 exists. So make little queries. Think about little panels of pages rather than trying to just satisfy everything. And I think Relay is a really unhelpful pattern for this. Apollo is maybe a little bit easier. Our realization was maybe a little bit deeper than that, though. And I talked earlier that we had like a React client customer-facing front end and a graph providing it with data. If I can tell you one thing today, it's this next slide. For the love of whatever is out there, do not model an entire HTML DOM in GraphQL, pass it over the wire in JSON, and then ask React to render it on the other side. Honestly, it doesn't work well. But if you're in a situation where you're not analyzing the tools, and we weren't at this point, we had a fantastic solution to this. We worked out that the slowdown here was because GraphQL has to wrap every single node on that graph as a scalar. So we fixed it. We make JSONScalar. It's okay, what we do is we assert that this is JSON, and we pass it over the wire, and then we still render it in React. It was genius, like absolute Friday night pub genius. Also, if you do have a way of revoking commit privileges after like 6:30 on a Friday, I strongly recommend it. Also, can you tell me how I can do that for myself? That'd be great. I think it's really important with any of these things, especially where there's such a big framework. And like, we have this as well with our Rails platforms, where you get so engrossed with what you're doing and so enabled by the framework that you have to be able just to take a step back and think, you know what, that might be a solution, but is it the right solution? It might be, but it probably isn't. And having the discipline to do that in any programming setup at all, I think, is one of the most important things that you can find as a team, and one of the areas where great teams support themselves in just asking the difficult question, which is why? Not in a horrible and confrontational way, but just in a really genuinely, honestly, like, are we missing the point here kind of way? So we talked about this a little bit, I talked about this a little bit before, which is in terms of how we do business. So we took a step back from that React thing and we went, okay, well, we'll do Liquid. But because we went microservices, now we've got a situation where our rendering service needs lots and lots of data. So GraphQL is great for this. Like, you can just request everything. And if the data structures in the database have got the data in, it will return it. And if it doesn't, then you won't get that data. And it means that we can basically query with a path and just get back a representation of everything that should be on the page and then turn it into HTML. The problem with this, though, is that at 73 kilobytes worth of text that we're sending over the wire, even compressed, that is still way, way too much. And we'll talk about the scalability implications of that very shortly. Maybe that isn't the right approach. One of the things we toyed around with is it better to just hold up a process in the middle of render and say, oh, we need some more data now? We benchmark the two, and they're basically as rubbish as each other. Also, if anyone knows how to magically teleport data, I'm looking at you over there, then that would be great, you know. I want more magic data. So let's talk about the good things. And there are many, many good things. We'll cover the most important of them, in my opinion. Documentation. GraphQL has maybe the most simple way of generating documentation ever, which is that every single thing you define, and I totally have forgotten to put the code slide in here, So sorry about that. Every single thing you define has got a hook for documentation, and the Interactive Explorer displays it on every single field and every single type. And there is no excuse not to do it. I actually think that maybe the single greatest failing of the spec is that documentation is optional on it. I think having types is an interesting discussion. Lots of people, I do like types. Having tests is an interesting discussion. Like, I think lots of people, including myself, do like them. But at the same time, I think documentation beats tests if you had to pick one of the two of them. Because I don't know what I wrote last week. I can't expect other people who worked with us 4 years ago to have somehow mythically conveyed their intent through the ether that a new hire next year is going to pick up in a sensible and coherent way. The next amazing thing about it, and I'm aware this is a JS meetup, is language agnosticism. And I think this is maybe the single most important thing, and where we've maybe had some of the biggest benefits, is the fact that by defining a lot of the way you see your world in terms of the interactions and mutations, in terms of the way the data is modeled and interacts with itself in a spec rather than in code, you've got the opportunity to do the right thing at any moment. And if parts of it aren't going fast enough, then you can do it in a faster language. If parts of it are confusing, then you've got an actual coherent document to discuss and to argue about, or to iterate on to make it better. And I think that's definitely improved the quality of our engineering massively, is taking it away from code and making it actually about our business ideas and our business concepts. Visibility is maybe the next single biggest area where it is, and our first talk this evening about resolvers is a great example here. Because everything has a really well-defined way of being accessed, you also have great primitives to be able to actually interact with what's happening on a day-to-day basis. Like, when was the last time that field was used? And a simple stats-d implementation or something just allows you to say, oh, hasn't been used in a year. So you can just delete it and then regret it a year later because it's the biannual field or something. But no other solution that I'm aware of gives you quite the same ability to just drop in and say, well, what's the state of the world at the moment, and how do we work with that? Standardization, I think, is the other great thing here. And I touched on this slightly beforehand, which is, I think there's just far too much kind of like ego in our industry. We all want to be that like 10x or 100x engineer where, we deliver so much value to the team, to the company, to the pub on Friday night or not, as the case may be, and just feel great about where you are. But I think in order for us to improve working practices generally in this industry in London, we need to be able to take a step away from that and actually just talk a little bit more as humans about what's going on. The value we deliver is in our experience and how that interacts with the things we do. And in any situation where we're measuring our output based on the difficulty of the solutions that we're building, or the incredible engineering that's gone into this one thing, I think we've kind of missed the point slightly in 2018. Like, solutions like GraphQL actually provide a framework for enabling kind of like a demachismoing of the industry, and the possibility that we can have solid conversations about business ideas aside from like, well, that's an on+1 log n squared loop, and like, who cares? Like, it doesn't matter. Like, let's talk about the underlying concepts and let the framework guide us towards the finishing line in this. That might be a controversial point, but I think that by buying into it, there's an interesting thing you can ask yourself about actually what is it that we are doing on a daily basis. And the great thing about that is it makes hiring easier, because you don't need unicorns anymore. These standout developers are only this person can deliver the feature that we require. And like, we were in a situation like that significantly previously, where you've got some features where, well, it's going to have to be that person's feature because they're the expert in this area. You just make a team of experts and everything, because everyone's got the same shared understanding about how you actually implement and deliver stuff. And then just from a businessy point of view, and I think this is maybe one of our single biggest functions that we can serve outwards, is that we can de-escalate the risk in projects which we deliver. Now, no one really cares about that stuff. Like, I hate that side of things. But at the same time, I need to be able to turn around to the people I report into and say, you know what, actually we can do this, and it can happen on time, and it can happen on budget, and we can deliver value for money. And in the old world, we'd go and build out some super awesome system that used like message passing between Lua and like a goat. And then the goat doesn't speak like JSON or something, and then you've got to reinvent it again. And you just go, you know what, GraphQL actually is good enough, and we can run with that. So what's the bad? And there definitely is bad. One of them is that text is a lousy API, and in our experience, anything you transfer over the wire probably is going to get corrupted, and anything that you accept from a client is almost certainly going to get corrupted. I have no idea what happens in Sweden, but we have the most incredible amount of encoding errors coming out of like the Stockholm area. Apparently a curly brace is not a curly brace. And I'd love it if GraphQL had maybe a binary API that you could just flick to at compile time. Like literally nobody in the world, once you're out of development, needs to open Chrome DevTools and read out the response or request body to you. I think that would be a really nice improvement to where it goes. I think the single biggest issue for us, though, is this, which is that it is not a Ferrari. And we touched on this before about the overheads involved in wrapping fields and in actually processing any kind of great size GraphQL response. There is an underlying issue with JS and GraphQL, which is that they are not fantastic soulmates. They're a great solution for building early stage implementations of this, but at the kind of scale we've got to, there are issues caused by literally the choice of runtime. And the event loop causes us endless issues. We've experimented, but admittedly, we're still TypeScript at the moment. Like, we're still run on JavaScript, and I'm not saying that we're even having any plans on moving away from that, but we're definitely starting to think about how else can we pick up the GraphQL stuff and run it on other runtimes. Elixir's got some great traction. We've had a couple of projects in that. Absinthe is a lovely, lovely framework that does concurrency really well. In Scala, Sangria is another fantastic implementation of GraphQL, and both of them just offer you a little bit more rock solidity in the runtime level. And I think if you're getting 2 or 3 years into a project, then I think you should be asking yourselves, you know what, are we still in that rapid phase, or actually do we have some concepts now which have been lifted out of that and are a bit more solid? Apollo makes some fantastic stuff, being able to split schemas and send some to some backends. You can have your Scratchpad GraphQL one in JavaScript where you can iterate really quickly, and then as concepts become more hardwired into the business and more well-defined, then maybe you migrate that to something else. It also begs the question, why are the really good implementations named after alcohol? I've got no idea on that one. Having said that, though, the JS version is okay, and I mean okay in the best possible sense of the word. It's fantastically easy to get started with. Like well, admittedly, the GraphQL spec docs are a little bit interesting, but the actual community around the GraphQL JS implementation is fantastic. It's got so much in the way of libraries around it. It's got great tooling. There is absolutely nothing that can compete with firing up GraphQL for the first time and just seeing the light about your data on the page. And okay is probably where we want to be as engineers. Like, if it's good enough, why are we trying to iterate further than that? To push OK a little bit further, these are the things we've kind of dealt with in terms of scaling tactics. First of all, speculative querying costs money, like real terms money. The way we do it needs to be improved. I don't have a solution for that yet. Anyone wants to suggest some, then I'm always all ears. But try to keep your footprint to the smallest size possible. Cache absolutely everything that moves. And caching and cache invalidation get a really bad rep, but caching doesn't mean it has to be locked down for half an hour. Like, we have a maximum staleness factor of 7 seconds from the very front to the very back of our application in a series of 1-second caches. We just have little micro caches all the way along, and it's incredible the amount of load that can absorb over time without actually really worrying about stuff. You hit save, you change tabs, you hit refresh, and it's there, like, every time. But what it means is that we can take all the pressure off the hardest parts of the system. Caching resolvers is a tactic which we've kind of played around with, haven't really managed to make work yet, but I think there's a lot of mileage to go in there as well. Data loader is the absolute answer to everything. If you're not using it, you should be using it. Like data load your commute, data load like your dinner. Like it's a Facebook project. It's like one file. It's even smaller than Redux is, and it just batches queries. Like it's as simple as that. Gather up everything that happened in that tick of the event loop and send it in one go. Boom, all my data back, and then it deals with deduping and all that kind of stuff. It's just incredible. Query parsing is your worst enemy is another thing we found, which is we cache all of the queries as they come in. So our middleware will do preemptive caching of the GraphQL query and then allow that to slip out, like a least recently used kind of basis. That's pretty much the way forwards, but again, has some issues with it. And then if you are going to do auto-scaling, then make sure you auto-scale the event loop of JavaScript. JavaScript itself exposes really good metrics about how much time it's blocked or it's actually running for. And as soon as you've got contention, like as in when a promise resolves it, it's got to wait before it can actually kick into action and do something, then you've got people waiting and you've got latency stats increasing all the time. You can just hook that straight into Kubernetes or whatever other platform you're using and say, look, the moment I've got like 40% free in the event loop in terms of where we're doing in wait times, just give me another node. Like tear it down again the moment the numbers drop. But I think if you use CPU as your metric, you end up really, really badly placed in terms of doing it. We found that like auto-scaling off the event loop, idle factor is by far the best way. And then just to end up, I think the other thing we've realized is what is it powering? Like it doesn't matter having this incredible data layer if you're actually just doing it for no reason. And this is maybe slightly heretical, but I actually wrote some jQuery the other day. It was amazing, like just, 3 lines of code, no webpack, drop a script tag onto a page. Like, wow, this is the future. Or something. But for so many of the tasks that we immediately now turn to React and turn to GraphQL and all this stuff for, like you just don't need it. An HTML form tag, jQuery, all of these things are still perfectly valid ways of building solutions in 2018. And I think a lot of the problems that projects get into is by trying to bite off far too much and use the wrong technology choices right from the beginning of things rather than going, you know what, we're going to build a proof of concept. Let's just do it in something really fast and scaffoldy and see then if we actually need, do we generate enough pain to decide that we'll go further than that. Over time, systems also stabilize. You might start out with that kind of really loose and fluid world where we're moving fields around, but then actually, does it stay that way? Are we changing our queries ever? Why don't we just change the gRPC or something different in terms of getting our data? Like there's so much out there that you can just switch to later, and GraphQL does make that really possible because you specified it. Does your flexibility matter more than your latency? Some of these are questions. So to sum up, where next? For us, GraphQL has got us to the point we are at the moment, and I'm super grateful to it. We will be using it certainly for the next 3 years. Although I'm concerned that our usage of it is becoming less and less idiomatic. We're doing bigger and bigger speculative queries and not necessarily doing like the very small, nimble, I just need this bit things that it's really designed for. One of the things we're wondering is, can we just do it without the network? Like, build a schema, then use some rendering and just render out at that point and maybe see if that actually does a good job for us. And then also we're kind of wondering about where we stand with monoliths and GraphQL, because our main graph is absolutely massive. It is a 3.2 gigabyte runtime JS V8, and that now needs to be addressed. But it's been great, and I'd recommend it to absolutely anyone as the way forwards for building data-driven applications in 2018. So much so that if this hasn't made any sense, I do actually apparently know what I'm talking about, and I would be very happy to help anyone that's got any questions about it. Feel free to drop me a line. I'm at JGW Maxwell on Twitter, or just come and see me. We would love to see this community do more, and it's one of the great things about you guys at Trint opening up your space to us this evening is if we actually collaborate, then there's a chance that London can maybe take a step forward in the overall tech scene, which would be awesome. Cheers. Thank you.